In this video, we are going to look at the product rule. Suppose we have y equal to ex. Then we know that the derivative of y is equal to ex. Suppose y equals sin x. Then we know the derivative of y is equal to cos x. But what if y is equal to ex times sin x? Then, what is the derivative of this? We may think the derivative of ex times sin x is just the derivative of ex times the derivative of sin x. This is not the case. Let us look at an example of why this is not the case. If y is equal to x squared, we know that the derivative is 2x. But we can consider y as x times x. And if we apply our logic, we may believe that the derivative of y is just 1 times 1. But it should be derivative of y is 2x. So it is not the case that the derivative of a product would be the derivative of each term multiplied. We don't always need to use a rule though. In this example, y equals x squared times x plus 1, we can just open the brackets into x cubed plus x squared and then calculate the derivative normally. Power comes down and the power loses 1. 3x squared plus 2x is the derivative. A moment ago I said that the derivative of a product is not the derivative of each term multiplied. Let's try to find the rule for what the derivative of the product is. So suppose y is equal to fx times gx. We know that the derivative of y will be the limit as h goes to 0 of the function evaluated at x plus h minus the function evaluated at x all over h. Like so. I will add and subtract a term on the numerator to simplify this expression. In red you see that I've subtracted fx times gx plus h and added fx times gx plus h. Net result is no change. But in green you'll see that I have gx plus h in common with the first two terms and fx in common with the last two terms. Factor in the gx plus h out and factor in the fx out, I'm left with gx plus h times fx plus h minus fx and then fx times gx plus h minus gx all over h. I shall split my fraction into two, each term over h, so it is really the same thing since fractions with the same denominator can be added together directly. But you'll notice that if I put the limit on each of these fractions, I'll have on the left the definition of the derivative of f and on the right the definition of the derivative of g. Making h go to 0 and I have gx f derivative x plus fx times g derivative x, or equivalently f derivative g plus fg derivative. Let's look at an example using this rule. What is the derivative of x squared times ex? Well, y equal to x squared times ex is of the form f times g. And applying our rule, it should be the derivative of the first function, keeping the second function the same, plus the first function times derivative of the second function. So in this case, derivative of x squared is 2x, keep ex the same, plus keep x squared the same, times derivative of ex, which is ex. There's an ex in common. I will factor that out, and my answer is ex times 2 plus x. Let's look at another example. What is the derivative of sine x times natural log x? Sine x times log x is of the form a function times a function. And so the derivative of this will be derivative of the first function times the second function plus the first function times derivative of the second function. Derivative of sine is cos. Keep log the same. Now keep sine the same. And derivative of log is 1 over x. Here's one I want you to try. What is the derivative of ex times sine x, which was the original question I posed at the start of the video. Pause the video, try the question, and resume when you're ready to see the answer. Y equals ex sine x is of the form f times g. And so we use our rule again. F derivative g plus fg derivative. So beginning, derivative of ex is ex. Keep sine x the same. Plus keep ex the same. And derivative of sine x, which is cos x. Ex is in common to both terms. I shall factor this out, giving me an answer of ex times sine x plus cos x. That's all for the product rule.